Section 5.6, half-angle identities. Here's our half-angle identities for cosine, sine, and tangent. You can review them further in the book. Our first example, we want to determine whether the positive or negative square root should be selected. Here I have the sine of 115 degrees. 115 degrees is in quadrant 2. And in quadrant 2, I know that the sine function is positive. Here I have tangent of a negative 35 degrees. And a negative 35 degrees is in quadrant 4. Tangent in quadrant 4 is negative. In this example, they want me to find the exact value using half-angle identities. For sine of pi over 8, I'm going to use this half-angle identity. The first thing I need to determine is the value of a. I know that pi over 8 is equal to my a over 2. Therefore, I can just solve for a. Pi over 8 equals a over 2. Multiply by 2 on both sides. That tells me that a is equal to pi over 4. I also know that pi over 8 is going to be in quadrant 1. Therefore, the square root I'm going to use is going to be positive. Now I can just substitute in square root of 1 minus cosine of a, which is pi over 4, all over 2. I can continue to simplify. 1 minus, I know the cosine of pi over 4, that is going to be the square root of 2 over 2, all over 2. And I can find a common denominator for my numerator. That gives me the square root of 2 over 2 minus the square root of 2 over 2 is 2 minus the square root of 2 over 2, and that would be all over 2 again. Then I would just invert and multiply this 2, which would give me the square root of 2 minus the square root of 2 all over 4. Then, when I simplify, that's the square root of 2 minus the square root of 2 all over the square root of 4, which I know is 2. And that is my exact value. Again, I want to find the exact value. I have that a over 2 is equal to 15. Solving for a, I can get a equal to 30. Now I'm going to use this half-angle identity. I know 15 degrees is in quadrant 1, and cosine in quadrant 1 is positive. Now I can just substitute into my half-angle identity, 1 plus cosine of 30 all over 2, which equals, simplify again, 1 plus cosine of 30 is the square root of 3 over 2, all over 2. Again, finding a common denominator for my numerator is going to give me 2 over 2, which is 2 plus the square root of 3, all over 2, again, all over that 2. I can invert and multiply. That's going to give me the square root of 2 plus the square root of 3 all over 4. But I know the square root of 4 is 2. Therefore, the square root of 2 plus the square root of 3 all over 2. Again, they want me to find the exact value. Here I have the tangent of 22.5. That is in quadrant 1, and tangent in quadrant 1 is going to be positive. I also know that if I set 22.5 equal to a over 2 and multiply by 2, that's going to give me a equal to 45 degrees. I'm going to select this half-angle identity because if I end up with radicals in denominator, I'll end up with a situation that I only need to rationalize, not find the conjugate. So let's substitute in. That's going to give me 1 minus the cosine of 45 degrees over the sine of 45 degrees. And I know those values because they're part of the unit circle. And that gives me cosine of 45 to be the square root of 2 over 2. And the square root of 2 over 2. Now what I need to do is to invert and multiply. So that will give me 2 over the square root of 2 times 1 minus the square root of 2 over 2. And when I multiply, that's going to give me 2 over the square root of 2 minus 1. Find a common denominator, multiply by the square root of 2 over the square root of 2, gives me 2 minus the square root of 2 over the square root of 2. Now all I have to do is to rationalize. Multiply the top and bottom by the square root of 2. From the numerator, I need to distribute. That gives me 2 square roots of 2 minus the square root of 2 times the square root of 2 is 2, all over 2. I can factor the numerator. And when I do, that gives me 2 times the square root of 2 minus 1, all over 2. Then I can just simplify, which leaves me with the solution of the square root of 2 minus 1. Here they want me to find each of the following. I want to find the cosine of theta over 2, given the cosine of theta equals 2/3. In other words, this would be a over 2, and this would be our a. So what I want to do is first determine where our angle is going to lie. If I have theta over 2, that means I have to divide both sides by 2. That gives me pi. And that's going to give me 3 pi over 4. That tells me I'm going to lie in quadrant 2. And cosine in quadrant 2 is going to be negative. So I need to use the identity for the half angle of cosine, which cosine of theta over 2 equals, and I need to be negative, square root of 1 plus cosine of a all over 2. And I'm given our cosine of a, or cosine of theta, to be 2/3, so I just substitute in. That gives me a negative square root 1 plus 2/3 over 2. Now, all I need to do is find a common denominator in the numerator. Gives me a negative. 3 over 3 gives me 5/3 over 2. And when I invert and multiply, that's going to give me a negative square root of 5/6. But I cannot have a radical in the denominator, which is the square root of 6. So I'm going to multiply the top and bottom by the square root of 6. That gives me a negative. Square root of 5 times the square root of 6 is the square root of 30, all over 6. Again, find each of the following. I want to find the cotangent of theta over 2, given the tangent of theta equals a negative the square root of 5 over 2. And I am between 90 and 180, and that tells me I'm in quadrant 2. And I know that in quadrant 2, I'm going to be negative with tangent and cotangent. The first thing I need to do is to get our values of sine or cosine. So I need to somehow relate my tangent to a sine or cosine. The way to do that is to use an identity that we are familiar with, which is the secant squared theta equals 1 plus tangent squared theta. Then I can just substitute in. That gives me secant squared theta equal to 1 plus, and I know that tangent theta is a negative square root of 5 over 2. When I square that, I'm going to get a positive 5/4. And when I add 5/4 to 1, that's going to give me a value of 9/4. Therefore, secant squared is 9/4. And when I take the square root of that, that's going to give me secant of theta equal to 3/2. And I know that secant in quadrant 2 is negative. And that tells me that the reciprocal of secant is cosine. And that tells me that cosine theta is just the reciprocal, which is going to be 2/3. But I also know that that's in quadrant 2 and cosine is negative. Now, using another identity we know is the Pythagorean identity, which we know is sine squared theta plus cosine squared theta equals 1. I just determined cosine squared theta, and I can substitute in sine squared theta plus squaring our prior solution, which I know is going to be 4/9. Subtract 4/9 on both sides, I get sine squared theta equal to 1 minus 4/9. And when I solve for that, that's going to give me a value of 5/9. And I can take the square root of both sides. That gives me sine theta equal to the square root of 5 over 3. But sine in quadrant 2 is positive. Now, I know that the cotangent is theta over 2, and that's what I need to solve for. By a reciprocal identity, I know that that is 1 over the tangent of theta over 2. And when I use my half angle identity for tangent, that gives me 1 over sine theta over 1 plus cosine theta. One divided by sine theta plus over 1 plus cosine theta, invert and multiply. That gives me 1 plus cosine theta over sine theta. But I've already determined these values, so now all I need to do is substitute in 1 plus cosine theta. I've already determined to be a negative 2/3. And sine theta, I determined to be a positive square root of 5 over 3. And when I simplify the numerator, that gives me 1/3 over the square root of 5 over 3. And when I invert and multiply, that gives me 1 over the square root of 5. And when I rationalize, that's going to give me the square root of 5 over 5. And that value should turn out positive, because if I would have theta over 2, I'd divide both sides by 2. That would give me 45 and 90. Therefore, theta over 2 lies between 45 and 90, and cotangent is positive in quadrant 1. Here I want to use an identity to write each expression as a single trig function. I'm given the value of a is actually 5a. So all I have to do is substitute in tangent. A is represented by 5a here. Therefore, when I substitute in, that gives me tangent of 5a over 2, or I can actually simplify it to be tangent of 2.5a. Again, they want me to use an identity to write each expression as a single trig function. Here I have the plus or minus square root of 1 minus cosine 3 theta over 5 all over 2. That is represented by sine of a over 2, which is a half angle identity that represents this. I know my a value is 3 theta over 5. That's all over 2. When I invert and multiply, that gives me the sine of 3 theta over 10. In this example, I want to verify that each equation is an identity. Let's start on a more complicated side. Since this expression is squared, I'm going to write it as a product of its factors. That's going to give me the sine of x over 2 plus cosine x over 2 times the sine of x over 2 plus the cosine of x over 2. So let's FOIL this. That gives me sine squared of x over 2 plus, that gives me sine x over 2 cosine x over 2. That gives me sine x over 2 cosine x over 2. Combining like terms gives me 2 sine of x over 2 cosine x over 2. And then my last term is cosine squared x over 2. But if I take a look at this and that term added together, that is an identity. That's one of our Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. Theta could just be x over 2. So that means I can have 1 plus 2 sine x over 2 cosine x over 2. But from our previous section, I know that this is a double angle identity. Therefore, what I can do is substitute the double angle identity. So that gives me 1 plus, and the double angle identity is sine 2 times theta, which is x over 2. Then I can simplify in my parentheses, which is going to give me 1 plus sine of x. Here they want me to simplify this expression. I know that I have the tangent of x over 2 times the tangent of x plus 1. I have a half angle identity for tangent of x over 2, so I can just substitute that value in. I'm going to use 1 minus cosine x over sine x. I decided to use that one because I know an identity for tangent of x. That happens to be the sine of x over cosine of x. And don't forget the plus 1. So knowing ahead that I can have this cancel out helps me a lot. So that gives me 1 minus the cosine of x over the cosine of x plus 1. But this has to go into both. That gives me 1 over cosine of x minus cosine of x over cosine of x is 1 plus 1. And that just leaves me, when the 1's cancel out, 1 over cosine x. But I know that reciprocal identity is secant x.